What is the difference between AMS and conventional radiocarbon dating? Imagine trying to figure out the age of ancient artifacts, but each method has its own way of doing it. That's what we're here to explore today. Both accelerator mass spectrometry and conventional radiocarbon dating are tools scientists use to find out how old organic materials are. They both measure carbon-14, but they do it very differently. Conventional radiocarbon dating, also called beta counting, works by detecting the radioactivity emitted as carbon-14 atoms decay over time. It needs about 1 gram of sample, which can be quite a bit of material. This process can take from several days to a few weeks because scientists wait for enough decay signals to stand out from background noise. It's a reliable method but requires larger samples and more time. Now, accelerator mass spectrometry, or AMS, takes a different approach. Instead of waiting for decay, it counts the actual number of carbon-14 atoms directly. To do this, the sample is turned into ions and then accelerated through a mass spectrometer. This device separates atoms based on their mass, allowing scientists to measure the amount of carbon-14 precisely. Because AMS counts atoms directly, it only needs tiny samples, sometimes just 20 to 50 milligrams, which is less than a grain of rice. This makes it perfect for dating small or precious objects like tiny seeds, small bones, or fragments of textiles. Speed is another big difference. AMS can produce results much faster than conventional methods, often within a day or two. It also detects lower levels of carbon-14, which means it can date older samples that might be beyond the reach of beta counting. This ability to work with tiny samples and older materials has made AMS a favorite in archaeological science. It allows researchers to date artifacts without destroying large parts of them, which is a big plus. Both methods are still used today, but AMS has become the go-to technique for many projects because of its speed, sensitivity, and minimal sample needs. It has really changed how archaeologists approach dating, opening new doors for understanding ancient history.